Welcome to the Monogoto webinar series about kickstarting your cellular IoT journey. So we will be waiting a few more minutes, allowing people to join this webinar, and then we are going to dive in today's content. So if you're joining in, please say hi, let me know who you are and where you are calling in from. So there is a chat feature somewhere at the bottom of this page. And if you have any questions along the way, then feel free to ask it and I'll be addressing them at the end of this webinar. Great. So quickly introduce myself. So my name is Lawrence. I am the developer community manager of Monogoto, and I'll be your host for today. And I'm actually really excited to get started because we are not only going to talk about IoT, but in fact, we will go hands-on. And I'm a little bit nervous, I have to admit, because I will be giving a live demo on how to build your end-to-end cellular IoT application. And for that, we are gonna use the Sodaxara dev kit, but actually the whole content and everything that I'm discussing today is hardware agnostic. So as long as you have access to a cellular modem, you can follow along. And so this is I hope you can see it. So this is the development kit that we're going to use today. And as you can see here, it contains the u-blox cellular modem. Perfect. Great. I already see the first messages coming in. Marco from Italy. Great. Thanks a lot for joining in. Patrick from Ireland. Ronald from Colombia. So beauteous. So there will be some people that also joined in last week, and there might also be some people joining in for the second time in a row. So I'll do a very short recap. So for the people that are new and didn't manage to join last week's session, that that you can follow along as well. So during today's workshop, I will be giving a demonstration and I will allow you to join in yourself as well. And this is optional only if you have access to a cellular modem and if you can set it up in such a way that you can directly send AT commands to that cellular modem. And in that way, you can configure the modem to connect it to Monogoto and eventually start sending data to the cloud where you can analyze and process the data. If you're a little bit puzzled about what I just mentioned, then that's all fine. You can just watch. Everything will be recorded. I'll be sharing the slides. I'll be sharing the recording in a day or two. And directly after this webinar, I'll also be sharing my personal notes and a tutorial on how to kind of redo all the steps that I've been going through. So let me share my screen and then we should be able to get started in a second. Okay. Perfect. Great. Okay, I see. I think we have a decent group now joining in. So let's get started. So today we're going to dive into kickstarting your cellular IoT journey. And everything today will be about building an end-to-end IoT application from scratch. And we only have 1 hour. So the demonstration that I will go through will be very fast. So don't worry if you cannot keep up, because as I mentioned, I will be sharing the recording as well as the slides and all the tutorial to replicate this process. So as I mentioned, my name is Lawrence. I'm the developer community manager at Monogoto, and I'll be the host for today's session. And today we're going to cover a couple of interesting subjects, and we are starting, and that's partly a recap from last week on how the IoT architecture actually looks like. So what are the different elements of an IoT solution that you need to take into the consideration? The next step is I will give you an introduction to AT commands. And that is the common language, the standardized language to configure cellular modems. And once that is all done, then actually the fun part begins, which is that we can actually start sending data to specific endpoints in the cloud. And meanwhile, I'll tell you a little bit more about Monogoto, about who we are and what we offer for IoT developers. And foremost, I would like to stress that this is not only focused on, so this developer series is not only focusing on those webinars that I'm hosting today, but I'm happy to say that we also announced that we launched a Monogoto community. And you can join in via community.monogoto.io. And this will be the place where we gather IoT developers. I'll be active there as well as many Monogoto experts to support you in your IoT journey. And this will be the central place where everyone gathers and where everyone can exchange ideas and help each other to bring all of our IoT ideas into reality. Starting with the IoT architecture. So 4 different elements that you need to take into account. So the first part is what we call the UE, the user equipment. And that is the end device that most of the time initiates the conversation with the network. And the UE needs to have a cellular modem, which is kind of the essential part to make it work with the cellular IoT technologies. It often comes with some embedded sensors to kind of sense its physical phenomena and use that to send the sensor data over the air. And it sends it over the air to what we call eNode Bs. And those are the cell towers that receive data and also send the data back to the device where needed. And those eNode Bs, they are in direct connection to the core network. And the core network in our in this series is Monogoto, and Monogoto routes the data to the right endpoint in the cloud. And Monogoto is also responsible for the device management. And you will learn a little bit more about what this works and what this means in a minute. And then eventually you want the data to end up somewhere. So that will be a database or a cloud platform. And during today's session, during today's demonstration, as I mentioned, we are using the Soda Xara with the onboard u-blox cellular modem. And that modem supports LTM, narrowband IoT, and 2G. And we're mostly going to focus on LTM communication. So the beauty about working with Monogoto is that we have partnerships with about 500 networks around the globe. And so Monogoto itself does not have any physical infrastructure, but it collaborates with many networks around the world, from AT&T to Vodafone to T-Mobile, and you name it. And so you can use your network of choice during this workshop. So we have to set the APN, and that results in data going to Monogoto. And we'll use HTTP or HTTPS to eventually send the data from the UE all the way to a platform that is called webhook.site, which is a very easy tool to test if the connection is working. And eventually we end up with if this then that. And that's one of my favorites, testing prototyping platforms where you can connect these webhooks and trigger specific alerts. So I'll show you more about that in a minute. And again, don't worry if this is all new to you. I'll try to go through all the content slowly, and it's fine if you are not able to follow along hands-on, because as I mentioned, I'll be sharing all details later on. So AT commands. AT commands is a standard language to configure cellular modems. And it's standardized between quotes because many manufacturers adhere to a specific version of a release, of a standard released by the 3GPP. And everyone always comes with vendor specific commands as well. So I really want to stress that that before starting any configuration to any modem, always make sure to look up the AT commands manual that is always provided at one of the websites of the modem manufacturer. But the topics that we're discussing today, those are relatively vendor specific. So you might actually get away with using the same commands during this whole process. So as I mentioned, it's a standardized way to instruct cellular modems. And these instructions are about scanning for networks, connecting to a specific networks, but you can also use the AT commands to send data or to enter sleep mode. And there are plenty of other functions. And as I mentioned, so these modem manufacturers adhere to a specific version of a standard defined by the 3GPP, which is the association responsible for all these cellular communication technologies, but they also implement vendor-specific commands. So always keep in mind that what works for the one modem does not necessarily works for a modem from a different manufacturer. And the very basics is that you have a host, and during this demonstration, this will be my PC, my laptop, but in a normal use case, this is your MCU or an embedded device, and you write a program to instruct the cellular modem at specific times to execute a specific task. For example, if a temperature passes a specific threshold, then the MCU instructs the modem to send that temperature data. And so the host sends the AT command and the modem always responds. And if you do not get a response, then the AT command did not arrive. So always keep that in mind. So there are 4 different kinds of AT commands. So there is the command to set a specific value to a parameter. And for example, AT plus CFAN is 1. So CFAN is the command to activate the cellular modem. So if you put it to 1, then you activate it. If you put it to 0, then you deactivate the modem. If you read, the read command is always ends with a question mark. And if you send the command AT plus CFAN question mark, then you query the current state of the modem. And then it will return, if you first activated it, and then you query what the state is, then it will return you that it is activated. So another command is about testing. So you can test what all the available variables are. And finally, there's the execution command, and it states, I want you to execute a specific task. And CSQ is about returning the radio signal strength of a specific network. I will show you in a bit how this exactly works. When I'm going through when I'm configuring a cellular device, then I'm always going through those 4 different steps. So it's important that you keep that into mind. So I start with querying modem information. So, okay, what is the firmware that the modem uses? Does it use the latest version, or is there a new version available already? And do I might need to update the firmware? You can also query if the modem recognizes the SIM. If the SIM is not locked, for example. You can also query the IMSI, CCID, etc. So once you have the right information, then you can continue and configure the network. So you can configure the radio access technology. So whether you want to use LTM or another type of technology, you can set the mobile network operator or the specific bands. So once you configure that network, then you can start activating the network. And it means set the APN and activate the PDP context, which is the packet domain protocol that we will cover in a minute. And also you can validate the IP address to check if the modem establishes a proper connection with the network. And then the final step is actually start sending data. So enough talking. Let's actually get to work and start this demonstration. And the essence is that you want to be able to control the cellular modem directly from your PC for this demonstration. So in my case, I'm using the Arduino IDE, and it uses the serial monitor, and you can use that to directly connect to the modem. But you can also use a terminal program, and for Linux or Mac, you can use Screen or Minicom. For Windows, you can use PuTTY, and that's kind of the way to directly get in touch with, or one of the tools to directly get in touch with the cellular modem. And everything that I'm discussing here, it's already documented for different cellular modems. So feel free to head over to docs.monogoto.io, and then under the section device configurations, you find all the IoT modules. And then you can select the u-blocks, SARA, or any other modem. And if you want to follow along with the same device, then there's even a tutorial on the SODAC SARA dev kit. So there we go. Let's have a look. So it all starts with, okay, so we have this development kit. So first I'm gonna connect it to my laptop using a micro USB cable. So let's start there. And trying to get both screens in one page. And that will look something like this. Okay. So let's first test if we can actually communicate with this cellular modem. So we always do that by sending AT. And if everything is set up correctly, then the modem will respond with OK. So if you see this OK message, then you know for sure, OK, we have a solid connection and now we can move forward. So I personally always start with AT plus CPIN is 1.1, and that's a reboot of the modem. And it could be that there's still some temporary settings that you yourself or anyone else configured in the beginning that you might want to get rid of. So I always start with that command just to be sure. The next one I always do is AT plus CMEE is 2, and that set the error reporting to verbose. And it makes that allows, if you make a mistake along the way, then the modem reports more descriptive error messages, which might come in handy. And then you want to validate if the modem actually sees the pin or sees the SIM. So you do that with AT plus C pin. And here we're getting an error, and that's actually true because I haven't yet inserted the SIM. So let me do that now and see if that makes any difference. And it sometimes takes a little bit of time before the modem recognizes the SIM itself. So what you can do here is do a quick reboot. You might need to wait a few seconds, and then if all goes well, then it should recognize the SIM. And there we go. So you might want to query the modem information, so it can be done with ATI. Then you see some generic information. What's important here is that it also returns you the modem version. And you can use this modem version to actually compare it to the latest version available. Next up is the IMSI, which might come in handy to know that, and that is the identifier for your SIM, and as well as the CCID, which is actually the unique code associated with your SIM. So this is more or less the first step. So we made sure that we have a good connection with the SIM itself and that we queried the right modem information. So the next step is trying to connect the modem to a specific network. And this is a very important command that you really need to know by heart, COPS. And what we can do, and in some cases, the modem directly connects to a network. So you can actually read if the modem is already connected to any network. And as we can see here, it is not. And there are two ways to go about. So we can set AT COPS to 0, and then you allow the modem to select the network as well as the radio access technology itself. But what you can also do is to manually configure a network, manually configure a radio technology. And this is really important to understand. It can really take quite a long time before the modem actually scans the networks and find a suitable network to connect with. And another important command that I want to run is AT plus COPS equals ? And this command instructs the modem to search for all available radio networks in reach. And it's very interesting to see that it might return you basically all the available networks as well as the radio technologies. But as you can see already, this can take quite a long time. And fortunately, we already have a response. So you can see that in my area, there is T-Mobile, there is KPN, and there is Vodafone available. So we have some networks that we can choose from. And this final digit that indicates the technology that those networks support. And again, check the AT commands manual what these digits exactly represent. Because it can also differ per vendor what digits represent what specific technology. So I looked it up already. So 7 indicates LTE-M, and we might have different numbers. Yeah, so we have a 0, and that represents 2G. And I think these are the numbers that we are seeing now. So, well, let's give it a try. So what we can do is select a specific network that we want to connect with. So what you can do using this command, and to specify a network, the best is to use what we call the MCC-MNC, and that is a unique operator code that links to a specific operator. So I don't know, let's say we want to connect to Vodafone, and then this specific code that we want to use is 20404. There we go, and we already have a response. And then we can test if it's actually properly connected, and it does. So I managed to connect the modem to Vodafone. But what you can see here, that this final digit, it states a 3. And a 3 represents GPRS, if I'm not correct. So that's one of the 2G technologies. So I actually want to connect it to LTE-M. And hopefully this is gonna work. because I know that in my area, the network connection is not always of a very high quality, but it seems that I already have a response. So if I then get conduct CUPS, then I'm even seeing a different number, which is interesting. Let's have a look first into the signal quality. So there's this execution command that actually queries, okay, so what's the radio signal quality? And you want to look at this first number, and this number ranges from 0 to 31. And the higher this number, the better quality the signal. And so if you have it to 28, then that's actually quite a relatively good signal. Although I have to say, I'm not really sure what this 11 represents. So I'm trying to do this command one more time. Hopefully that will lead to the modem to actually start using LTE technology. And there we go. So now it did actually follow up on my command, and it started using LTE technology. Great, so far. This is still exciting, right? So we're actually configuring the modem as we go. Important to remember, so the APN, which is the next step, we go to network activation, is data.mono. And those are, here you can find some longer commands. So I actually already wrote them down in order to avoid making mistakes. So to set the APN, we have this specific command. And yeah, most important is that you set this data.mono. And like I mentioned before, you can first execute the command, and then you can always validate afterwards if actually the settings were the parameters were set correctly. So let me validate if we actually manage to properly set the APN. And there we go. So we see here that the APN is set properly. So next up is that you want to activate the PDP context. And that in fact is the context that it represents that you have an active session with the network. So you want to activate that. And then the big test comes if the device actually received an IP address. And if you did receive an IP address, then you know that the connection has been properly established. And guess what? We do see an IP address. So that means that the modem is now successfully connected to a local cell, to a local eNode B that connects it to Monogoto, and using that way, it retrieves an IP address. So hopefully everyone still follows along, because they're slowly, we're actually going to the very exciting part, which is actually sending data. And for everyone who did receive a dev kit, or who did receive a Monogoto SIM, also received access to the management portal. And we have a hub.monogoto.io, and you can use that to monitor all of your SIMs. And you can find an overview of all of your SIMs that what we call things. And then you can see if the SIM is active, and you can also see what the last time when the network has seen the SIM, which is actually very handy for debugging. And there's some additional information like the current network, the data usage, etc. And what I really like about the hub is that you can initiate integrations. So you can define specific alerts. So for example, if the modem or if the SIM surpasses, let's say 50 MB, that you want to get a notification. Or if the device goes offline, then you can configure a notification. And there are kind of some different elements to do so. And these notifications, you can connect a specific webhook or send an automated email or connect it to Slack or to different platforms, and really to streamline the developer experience. So a few key features of the Monogoto device management is, well, like I mentioned, you can set up alerts, really making sure that the device work as it should be, and if not, that you as a developer are directly informed. You can define integrations, so with Slack, and we're also working on AWS and Azure and different application that you're familiar with. And you can all configure this one by one, but you can also create groups of SIMs and then configure all of these settings at once. You might want to have specific mobile operators that you want to work with or prefer not to work with. So in the device management portal, you can enable or disable specific MNOs. And also from the portal, you can send a ping or an SMS. And that's an easy way to validate if the device is still online and responsive. And finally, for security purposes, you can even set up a VPN, enhancing the security of your device. And the beauty is this can be done via the web console, but it can also be done via the APIs. So there's no need to use the graphical user interface, but you can fully embed all of these features into your own platform of choice. Then we go to the final part, which is the most exciting part. So we're actually going to send data. So what we're going to do today is that we are sending data using HTTP. And there are different communication protocols that all of these modems support. So today we're using HTTP. And actually at the end of this course, 2 weeks from now, we also learn how to use different communication protocols like UDP, TCP, or MQTT, and also diving into differences and supporting you to make a good decision about what communication protocol to use. And to test this out, I first want to work with webhook.site. And it's a very easy free website that allows you to easily play around and to test if the HTTP post messages are coming through. So we go back to our terminal program, and we're gonna prepare the first HTTP post message. And to do so, we are sending this specific command. So you HTTP, and then you define the base URL, which is webhook.site in this case. Next up is that, well, this is optional and depends on, of course, your endpoint, but you might, in many cases, you want to set a custom header. And in this case, you want to define that the data we send, that is JSON data. So we cannot define that in the header. And it's important to, so a common practice when sending data is that you store sensor values, or that you store the data that you want to send in a specific file. And when sending the message, then you refer to that specific file and you say to that modem, okay, I want you to send the contents of that specific file over HTTP. And we're going to use this in this example as well. So we're going to create a file that's called sensordata.json, which contains 19 characters. I counted them in advance, and I know we are faking it a little bit because we're faking the temperature. And obviously, if you have an IoT application running, then it queries or it checks the sensor values, and of course it sends this variable. But for this demonstration, we are faking the temperature data. And I've been talking too slowly, so let's have a look. Okay, so now I created a JSON file called sensor data.json that has that specific JSON string, and let's validate. So we're going to read this file. So sensor data.json containing 19 characters, and this is then the specific content of that JSON file. And then the most exciting part starts. So we actually gonna send this specific JSON file, and we're doing that with the following command. I already prepared this command in advance, so this is what it looks like. And this is the URL path that you found in your webhook.site if you open it up. So this is the base URL followed by the path, and you only want to use this path to in this AT command, starting with the slash. So you're sending this to that specific URL, and then you want to store the server response to this data.txt file, so you can review later on if the message was sent successfully. This relates to the message, the content of the message we're actually sending out. So it sends the content of this specific message, and this 4 indicates that it is sending JSON data. So let's have a look and see how this is working out. So it might take a second, and if everything goes well, then you see that this response is given. And if it ends with a 1, then that means that it is sent successfully. And we can also validate that by actually reading the server response. So as I mentioned before, the server response is stored in this file that we created called data.txt. So we can read this file. And if we look here, then we actually see that we get the response 200 OK, which is that the server response that it was successful. So the moment of truth, did it actually receive a message? And then we go back to a webhook.site, and we see that an actual message appears in our browser, highlighting that the temperature is 21 degrees. Okay, all good for now. So this is the basics, and normally you might have extra custom headers. So a common one is that you also add an authentication token to make sure that the data is sent to a secure endpoint. And then the final step for today's session is to initiate triggers, because that's the exciting part, that we don't only want to look at data, but we want to create an automated process based on sensor data that action is triggered. And then we go to one of my favorite platforms, which is if this then that. So we can visit the URL ifthisthenThat.com/create. And I'm going through the process of creating a new, what they call an app or an applet. And what we can do is that we define the trigger. And there are different triggers that you can define here. But in our case, we've been working with webhooks. So we are using as a trigger a webhook. And then what we can give it a name. So let's make it HTTP-trigger. You can choose anything you like. And we are creating this trigger. So if a trigger is received on this platform, then we want to execute an action. And this platform, you can allow tons and tons of, you can connect tons and tons of services, from connecting your Philips Hue light and changing the color to sending an automated text message or maybe an automated email. But in this demonstration, to actually make sure that this demo is live, I want to show you, and I want to send an automated tweet containing the temperature sensor that we defined. So I want to post a tweet. Well, I already connected my personal Twitter account. So if you want to validate that this is actually true and happening, then yeah, feel free to go to my Twitter account and have a look. And well, let's think of a fun message to send. Well, something like, this is an automated tweet triggered by an HTTP webhook sent from my Solak dev kit connected to Monogoto IoT using LTE technology. And then the fun part is you can even add the specific JSON payload to embed that variable in the tweet itself. So, well, we now have the full if then that applet configured. And then the next step, and you can go to maker.ifthisthenThat.com, and there you can find the details of the webhook that we need to post to. So if we click on documentation, and then we write down the name of the trigger that we defined, which is what we called HTTP-trigger, then we have the URL path that we need for the message that we're sending out. Okay, so the basics are done. Now let's see if this actually works. And if we manage to send an automated tweet when first sending a webhook or an HTTP post message from this u-blox modem. So what we are doing, we're creating a new base URL. And another feature of this u-blox modem is that you can configure multiple URLs, and you kind of update the first digits, highlighting that it's a new URL that we are making. So the base URL is maker.ifthisthenThat.com. So let's first set that. Then again, we need to create a custom header highlighting that we're sending JSON data. Well, we can validate, but the sensor data.json file should still be operational. And indeed, well, it still contains the data. Temperature is 21 degrees. And then the next step is to actually send the data. So for this, we can go back to our if this then that maker, and there we can find the specific path that we need to copy, starting from the first slash. So I already did some groundwork, and that comes down to this specific AT command. So we're using the path with this full URL. We want to store the HTTP response again in this data.txt file, and we're sending the content of the sensor data.json. So let's have a look. We're gonna send this message, and then it can always takes a moment, and then we see that it's sent, and the response ends with a 1, highlighting that it is sent correctly. Then we are reading the data.txt file to see if we get a proper response, and indeed we do see a response of 200, meaning that it's correct. And it even says, congratulations, you fired the HTTP trigger JSON event. So then this might always take a second, but let's go to my personal Twitter account, refresh, and then we don't see a message just yet, but it can always take a moment. So stay tuned. This is the moment of truth. Okay, I see that nothing yet appears. And you know what? Let's just try it again. And again, we see that, well, it did send it successfully. And let's see if it now. All right, there we go. So you can validate yourself. Not sure why it didn't work the first time, but here's the automated tweet that I just sent out. And it even includes this sensor data file that we created just before. So it seems to work. So this is the end of my demonstration showing how to configure a cellular modem, how to connect it to Monogoto, how to create specific, how to send sensor data using HTTP and eventually initiate a trigger or an alert via any channel. More information on how to accomplish this will be on our forum. So I'll be adding that directly after the end of this webinar. So if it all went a little bit too fast, then have a look at our forum and you can try it out yourself. And there's also more information about Monogoto, about the platform, but also how to work with different cellular modems on our documentation page. And that almost concludes the webinar on building an end-to-end application. So we have a few more minutes for questions, and then next week we'll be back again. And I'm very honored to have with me Jan Willem from Sodak. He is the founder of an IoT engineering firm. So he has lots of hands-on experience, and he is sharing all the information about optimizing the battery consumption of your end devices. And the week after, I'm joined by David from UbiDots, and then we're really diving into, okay, so what are the different data protocols, how to properly configure a custom endpoint, but also how to send data from a cloud service back to the device. And then it really brings the whole application to life. So thank you so much for joining in. It was a lot of fun hosting this for you. I'm really happy that the demo went okay. So yeah, we still have a few more minutes for questions. And if there's more you want to discuss, or if there's not enough time for me to discuss all the questions, then feel free to go to our forum and I'll be available there at any time. Okay, let's have a look if there are any questions. So there's this Q&A button at the bottom of this of your screen, so feel free to use it and ask me any question you like. So, well, first, everything is recorded. So I'll be sharing the recording afterwards. So you'll be receiving an email probably by tomorrow or the day after with a link. So Yasser asks, so are you connected to the modem via a serial connection? I didn't see any cables connected. Well, let's stop my screen share so you can actually see what my setup looks like. So yeah, there's a micro USB cable connected to this Arduino, and using that cable, I can directly configure the cellular modem. And at the other hand, this cable is connected to my laptop. Great to hear that UbiDots, that you received the SIM. So hopefully that provides you more enough time to prepare the presentation on connecting different endpoints. And it's a lot of fun. So I managed to set up everything to Monogoto, and if you like, so of course you can play around yourself. There's some sample application on the Sodak website. So if you have your hands on one of these boards, then you can flash it with some application and then start sending data right away. So there's a GPS tracker option, and you can track the temperature as well as the accelerometer. So different ways to sense physical phenomena and send that sensor value to send that over to a specific platform. And then UbiDots is a very good one to actually visualize and act on data that you receive. And now it's good to explain it as well. Of course, when you're really developing an IoT solution, then like you don't you don't work in the same way as I do. So you might do this in your testing or evaluation process, but eventually you're creating a script and you instruct the modem to behave in a certain way. And then you don't do anything manually, but you define a specific script that every now and then checks the sensor values, or it only does something if it receives a trigger from an accelerometer, for example, and uses that to trigger a message. It could be, so the last dev kits, as far as I understood, were only sent out today. So it might still take some time for some to receive it. And unfortunately, there was quite some demand for these dev kits. So we're not able to send a dev kit to everyone, unfortunately. We are able to send you evaluation SIMs. So if you have not received any, or if you would like to get one, make sure that you send me a message with your details and with your address, so I can ship over one of the SIMs, allowing you to start testing. Sergio, so there are some examples on the Monogoto website, on our documentation website. So let me directly send you the link. I'm going to attach it here. So if you go to docs.monogoto.io, then you open device configuration, and then you kind of specify the cellular modem that you are working with, and use that to use that as an example. And on the SODOC website, which I think is learn.sodoc.com, there are more examples. And I actually did some tries myself. So I will also share that on the forum. And if you have specific questions, or if you want to do something yourself and did not find the right example, then feel free to drop me a message or to send something on the forum, and we can try building something together. So Joste, so the SODOC SARA boards are quite similar, and this is I think this might be the board that you are having, which is very similar to what I'm having, but it has a different form factor, but it more or less uses the same. And up to my knowledge, if you're using the SARA R410, then that does not support 2G, which hopefully works in your area. So as long as you have a proper LTM network in your region, then, well, you can always use that. It's good to know that at Monogoto, we only start supporting narrowband IoT. And we will be supporting more networks throughout this year. So it might be that you cannot access any narrowband IoT network yet, but rest assured, we will support that as well. But for sure, you can start using LTM. Yeah, and indeed, Aksayan, you can always recharge the SIMs, and now I provided the people who requested it a free evaluation SIM with 500 MB, so it should be more than enough for all your testing and evaluation purposes. Because IoT data, like, we're not streaming Spotify or watching Netflix, we're only sending some sensor values, so you really consume very little data. So I can imagine you at least could use, I know you could use this 500 MB for at least a year, if not more. And indeed, you can recharge, you can request more SIMs, and we basically we create a payment account, and then it automatically charges a monthly fee, or if you surpass a certain thresholds. So Jan said, yeah, unfortunately, we were only limited to a handful of dev kits. So we are not able to send a development kit to everyone. But there are different development kits in the market, similar ones from Arduino, but there's also a very popular one from Nordic. I have one here as well. So it comes in different versions. So this is the NRF 9160. So this is kind of the bigger brother of the thingy 91, which is actually very, very nicely easy to work with DevKit. Feel free to post a message on the forum and I'll reply there with some suggestions on what development kits you can get. And indeed, we did start the webinar. So there's another question about the webinar of April 26th. On the forum, I posted a link to last week's recording. So I will make sure to highlight that so you can find the recording back. So Michael, some example in industrial automation PLC. I'm sure there are examples, not personally that I'm aware of. But yeah, I don't know. I'll be happy to think along with your use case and see if we can use existing hardware, or if we can create something ourselves. So again, feel free to drop me a message or to write me on the forum, and happy to think along with maybe some other Monogoto experts or different IoT developers. So I would like to conclude this second webinar series, and next week we're here again the same time, and then together with Sodak diving into the low power elements of an IoT use case. So thank you so much for listening in. It was a lot of fun hosting this session, and I would really hope that this can give you a little bit of help to start building your IoT solution yourself. And again, if there are any questions, if you need any support, I'm always available, and I'm happy to help out. Thank you so much, and I'll see you back next week.